right. Hi, everybody. We did an exit ticket working on solving quadratic equations and also on what type of answers we get from quadratic equations. You can really solve every quadratic equation with completing the square. You just may not want to do it that way. So the first problem here, if I'm asked to solve it, the numbers aren't so bad on this one. So I could complete the square on it. I could make a nice cute little box, x squared 2x and 2x to account for the 4x, making x plus 2 by x plus 2 on the outside of the box. 2 times 2 is 4. Everything is accounted for, so my box equals 0. The only way my box can equal 0 is if x plus 2 times itself equals 0. How do you solve? You take the square root of both sides, giving you x plus 2 equals 0. Subtracting 2 gives you x equals negative 2. Only number that solves that first one. On the second one, you can complete the square. It just kind of sucks because you've got the negative 5 in front of the x squared. 7's not a nice number, so it's just really going to be kind of nasty. So on number 2, I suggest practicing the quadratic formula where you've got your a, b, and c that you identify, and then you just plug everything in to the wonderful formula negative b plus or minus square root b squared minus 4ac, all divided by 2a. When you're working through this, I had a student ask me, can you just plug it all into your calculator? And the answer is yes. You have to do two different actions. You have to do a plus action and a minus action. And in my experience, I've seen more mistakes when people try to plug it all into their calculator than when they try to work it out piece by piece. That may not always be true, but I've seen a lot of mistakes with the parentheses because you've got to make sure you get the whole top answer and the bottom answer before you divide them. So really, if you wanted to type it into your calculator, you need parentheses around the entire top, and you need parentheses around the entire bottom. It's a lot of parentheses. There's a lot of spots for error. I think it's useful to be able to go through and break it down piece by piece. And then you can also leave your answer in exact form. So the way I break it down is I just calculate 7 squared and 4 times 5 times 2. So 4 times 5 is 20, times 2 is 40. 2 negatives make it into a positive, so I get 49 plus 40. 2 times 5 is 10, so I have negative 10 on the bottom. And I would leave my answer like this, negative 7 plus or minus root 89 over negative 10. Now, by the way, if you want to go ahead and skip ahead a minute or so, that's okay. I'm going to show you how you could have completed the square on this. This is optional viewing. This is just for your enrichment. I could have written the original problem like this. Divide by negative 5. To get just a single x squared by itself. Create a square where instead of 7/5, I have 7/10 because that's half as big. So that says negative 7/10 x in each of those squares. Completing the square to be x minus 7/10 on either side. 7 times 7 is 49. 10 times 10 is 100. But if I added in an extra 49 over 100, that was not part of the original problem. So I have to subtract 49 over 100 to keep things balanced. Remember that idea? If you go to the bank and borrow 49 hundredths, if you borrow 49 cents, okay, you got a 49-cent debt now. So if you set it up that way, you've got negative 5 times x minus 7/10 squared minus 49 cents plus 2 equals 0. Now again, you may not like it this way. I'm just trying to show you that you can solve it this way. You distribute the negative 5 to get negative 5 x minus 7/10 squared plus 49 over 20 plus 2. What I did there is negative times a negative makes a positive, and 5 over 100 is 20. So rather than multiplying 5 times 49, I divided 5 and 100 to make 20. Then I can combine those two pieces together. Let's see, I'm going to create a little bit of space for myself. Get this business out of the way. Let's scoot everything up here. Now I've got negative 5, x minus 7/10 squared, plus 89 over 20. Where did the 89 come from? Well, if I add 2, when I make it in terms of 20ths, 2 times 20 is 40. So I'm adding 40 20ths. Now you're solving it just like normal. So please notice, even though the numbers are harder, the steps I'm doing are the same steps that you did when you're completing the square and solving an easier problem. So now I've got negative 89 over 20. Divide both sides by negative 5. So two negatives make a positive now. So I have positive 89 over 100. There you go. There, the 100 is. Then I square root, giving me a positive and a negative answer. So I have plus or minus square root of 89, and the square root of 100 is 10. And then I add 7/10 to it. So I get 7/10 plus or minus square root of 89 over 10. Same answer I got over here. Same answer I got over here. So again, everything I just showed you in purple is optional. So if you were skipping from the red now, you're back on what I need you to know. The purple is just to show you that, yes, completing the square can solve it too. So sliding on down to the next part, we're just writing a quadratic equation with solutions that are not real numbers. Here's an example, x squared equals negative 1. That has the solutions plus or minus I. Here's another example, x squared plus 100 equals 0. That one doesn't have real solutions because if I try to solve it, I have to take the square root of negative 100, which is 10i. Here's a slightly harder one, x squared plus 20x plus 200 equals 0. I know that's not going to have real solutions because if I complete the square, 10 squared is 100, 200 minus 100 is 100. And if I try to solve this, I have to take the square root of negative 100, which makes x plus 10 equals plus or minus 10i. So x equals negative 10 plus or minus 10i. So there's an infinite number of equations that have not real solutions. What you need to have is you need to have b squared minus 4ac has to be a negative number. If this is true, then you have not real solutions. Okay? So that's that for the exit ticket. Please comment and ask questions if anything's confusing. That's where you should be at for now, except for the crazy completing the square example that I did on the other side of the page. So thanks for watching.